So this morning I was thinking about some of the most important formulas or important things that I've done in my career. And today I wanted to talk to you about expected value formulas. Expected value formulas are very, very valuable. To me, they have been valuable whether I'm doing analytics or whether I'm doing data science. And I thought about that because, we were talking about analytics earlier in the week. We were talking about SQL, Tableau, Power BI, things like that. And I have found them useful on both sides. For analytics, you can derive probabilities that you can then use for expected formulas. On the data science side, you can also derive mistakes, the probability of those mistakes, and then use those in expected value formulas. So what is an expected value formula? In a nutshell, an expected value formula tells you the financial result of decisions that you're going to be making based on probabilities. That's basically it. And by the way, you also might hear them referred to as EV formulas, EV, expected value. So very simple formula, two sides to the equation in expected value. Probability of success multiplied by the amount you're going to gain from that success. The second side is probability of failure, which is usually 1 minus the probability of success, right? Multiplied by what financial loss you'll incur in case of failure. And then you subtract one from the other. That's it. What is your probability of success? How much are you going to gain? Minus your probability of failure times how much that failure is going to cost you. And that result will be your expected value for all decisions going forward. Now, obviously, there's going to be fluctuations in between, right? Natural variance, as we all know from statistics. But over the long run, expected value formulas will tell you how much your decisions will either make you or cost you, right? Because expected value could be negative, right? So that's one of the things you should consider, or rather that you should know, because it's absolutely going to come in handy in the future. So like, for example, in the past, in some of my content, you've heard me talk about how sometimes the algorithm the business wants is not necessarily the best performing algorithm. You may be asked to shade an algorithm to have more false positives and false negatives. How do you do that? Well, you use an expected value formula. Or excuse me, not how do you do that, but how do you figure out those costs? Or how do you make those decisions, whether false positives or false negatives are where you should go? You use an expected value formula. Because the cost of those two might be completely different. The probabilities of those two are almost always going to be different, right? It'd be very rare to have an extremely balanced formula, right? Or algorithm, rather. So those are the types of conversations that you're going to be having with your stakeholders. Those are the types of formulas you're going to walk them through. Or in some cases, they may already know this. You will have stakeholders who are familiar with expected value formulas. They're not that rare. If you've taken some sort of statistics class or a probabilities class or, a BI course, you've probably come across expected value formulas, right? So sometimes the stakeholder might use that as their rationale for why they're asking you for an algorithm that's shaded in a particular way. So it's super valuable to know this. And I want you to look for opportunities to find how you can use an expected value formula. They're all around you. They're all around you. You just don't know it, right? People just don't look at the world in terms of expected value. What is the expected value of a lottery ticket? What is the expected value of buckling your seatbelt or not buckling your seatbelt when you go for a car ride? Right? What is the expected value of a new credit card offer that you received in the mail? They're all around you. They're not always easy to derive their probabilities, and sometimes the costs can be a little bit, something you might have to estimate or approximate. But expected value formulas, super important. Super important.